Hi National 5 and welcome to lesson 12 of Homologous Series. We're going to look at alkenes as monomers. Okay, there's no starter today because this is going to be a short lesson and we've got a lot of questions to do in teams. Okay, so we're going to get through this and then we'll get on with teams. Okay, now first things first, we need to know what a monomer is. So let's make a wee note here. So monomers are small molecules that can react together to form larger molecules. Okay, now these larger molecules are called polymers. Okay, so monomers join together to form polymers, and the reaction in a reaction called polymerization. Okay, so polymerization is a reaction where small molecules called monomers react together to form larger molecules called polymers. Okay, and that's very important. We go into that in a lot more detail when we go into plastics. We're not going to do that just now. We'll do that when we go back in August. However, today's lesson is going to be all about how to draw monomers. Okay, so monomers are drawn as a H shape. Okay, and an example of that would be like that. Okay, where A, B, C and D can be anything. It can be a H, it can be another carbon. It depends what the molecule is. What's important about that H shape is this here. The bit that goes across should always be carbon to carbon double bond. Okay, so the wee bit that, the wee bridging part, you could say, should always be carbon to carbon double bond. Okay, now the best way to do this is just to look at examples. Now let's look at the most basic alkene, which is ethene. Okay, now what you need to do is you need to get it into this shape first. So first things first is highlight the carbon to carbon double bond. Okay, and then draw it again. Okay, and again we can highlight it. Now get your H shape ready like that. Okay, and then all you have to do is plot it in. Now this carbon here is attached to a H, it's also attached to a H, so just draw that in. Yeah, so that's carbon 1, that's carbon 2, that's carbon 1, that's carbon 2. And then that carbon is attached to a H and a H, which is like that. Yeah, that's our monomer. Now that seems easy. It seems dead easy. It does get more complicated though. Okay. Let's go on to the next one. Let's do propene. Okay, and again draw your H shape ready to go, and then what we can do is we can highlight our carbon to carbon double bond. Yeah, and if we just number it, so that's carbon 1, 2 and 3, so that must be carbon 1, that must be carbon 2. Yeah, now look at carbon 1. Okay, what's that attached to? It's attached to two hydrogens, so we draw them in. 1, 2. What's carbon 2 attached to? Well, it's attached to a hydrogen, which we can draw in, yeah? But it's also attached to a carbon, so we draw that in, okay? And what's that carbon attached to? It's attached to 1, 2, 3 hydrogens, that's CH3. And that there is our monomer, okay? Let's go up to but-1ene. Okay. So again, if you get asked to draw a monomer, just make sure you're drawing your H shape. That's so important. Okay. So highlight it and number the carbons. So that's carbon 1, 2, so that's 1, 2, 3, 4. Yeah. Now, look at the first carbon. What's that bonded to? Well, bonded to 2 H's. Easy. Draw that in. Okay. Second carbon, what's that bonded to? It's bonded to a H. Nice and easy. Okay. What else is it bonded to? It's bonded to a C. Now this is where it gets a wee bit complicated because you have to, that carbon there is bonded to all this. Okay, so we need to simplify that. So in this molecule, how many carbons do we have? We've got, well, sorry, not molecule. In this section, how many carbons do we have? We've got 1, 2. So we write that, C2. And then how many H's do we have? 1, 2, 3, 4, 5. So we draw that, C2H5. Okay, and that's it. The important thing is that this H shape always remains. We always have that H shape. Let's go on to example 4. Let's go for, well, let's go for but-2ene this time. Just like that, yeah? So again, number it, so that's 1, 2, 3, 4. So get your H shape in, just like that, like it, and then number it as well. In fact, we'll highlight it first. So we'll highlight the carbon to carbon double bond, just like that, okay? And you'll notice this one's a wee bit more different, okay? So the carbon to carbon double bond is between carbons 2 and 3 this time. So this becomes carbon 2, this becomes carbon 3, okay? Now, just as we normally do, starting the left carbon, so carbon 2, what's it bonded to? It's bonded to a H, nice and easy. What else is it bonded to? Well, again, it's bonded to this here. So what do we see here? We've got a C and we've got 3 H's. Yeah? Now, carbon 3, what's that bonded to? It's bonded to a H. Place that there. And it's bonded to this here. So that is another CH3. Okay, and then what you should see is that's carbon 1, that's carbon 2, that's carbon 3, that's carbon 4. So that's how we draw but-2ene as a monomer. Now, you can also, because it's the exact same thing, draw it like that. Okay, so what we've done is we've taken the carbon 4 and we've switched that with the H there, so we've switched the 2 around. It's still the same molecule because the longest chain is still 4. Okay, it's still 1, 2, 3, 4. The double bond is between carbons 2 and 3, so that is but-2ene. But-2ene. It's the same thing. Okay? Now, will we do one more? Yeah, let's do one more, why not? 1, 2, 3, 4, 5, 6, 7. So again, this is a big one, but it's still the same process. Okay. Right, so draw our carbon to carbon double bond and then get our H shape like so. Yeah. We can highlight the carbon to carbon double bond, highlight the carbon to carbon double bond. What side's closest to the double bond? 1, 2, 3, 1, 2, 3, 4. So the left side. So 1, 2, 3, 4, 5, 6, 7. Yeah. So again, these two carbons here is carbon 3 and carbon 4. Now, what's carbon 3 bonded to? It's bonded to a H. Yeah. Carbon 4 also bonded to a H. Now, what else is carbon 3 bonded to? Let's split it up. Yeah, it's bonded to that. Now, what do we see here? We see 2 carbons and 1, 2, 3, 4, 5 hydrogens. Yeah? Carbon 4, what's that bonded to? It's bonded to 1, 2, 3 hydrogen, three carbons, sorry, and 1, 2, 3, 4, 5, 6, 7 hydrogens. And that is how you draw, what would this be, hept 3-ene. Yeah? So that there would be carbons 1 and 2, 1, 2, 3, 4, and then that would be carbons 5, 6, and 7. Just like that. Okay? Now, you might also be expected to go the other way. So you might get this drawn out here and you have to name this molecule just by looking at it. Okay, so again, always find your longest chain first and then name it that way. I've got some examples here ready for us, questions to try. So what I would like you to do, question 1, name and draw the following alkenes as monomers. So I want you to name them and then I want you to draw them as a monomer. And then question 2, I've drawn 3 monomers. I want you to name the alkene. Okay, so pause the video, do the questions, and then I'm going to go over the answers just now. So the very first one, A, nice and easy, it's just ethene, and if we want to draw that out, it looks like that. Nice and straightforward, not challenging. Next one, 1, 2, 3, 4. The carbon to carbon double bond is between carbons 1 and 2, so this here is but 1-ene. Yeah, and if we were to draw that out as a monomer, get your H shape like so. Carbon 1 is bonded to 2 H's, yeah, and then carbon 2 is bonded to a H, but it's also bonded to 2 carbons and 5 hydrogens. I might actually just highlight the carbon to carbon double bond like that. Yeah. Now this one here, what side do we start from? We start from the side closest to the double bond, so that's 1, 2, 1, 2, 3. So we start on the left side. 1, 2, 3, 4, 5. Carbon to carbon double bonds between 2 and 3. We take the lowest number, which is 2. So this is pent, because there's 5 carbons, pent 2-ene. Yeah, and if we want to draw that as a monomer, get the H shape like so. Carbon 2 is attached to a H. What else is carbon 2 attached to? Well, it's attached to a CH3. Carbon 3 is attached to a H. And carbon 3 is also attached to 2 carbons, 5 hydrogens. Yeah, 1, 2, and then 1, 2, 3, 4, 5. Getting it? I hope so. I hope you're getting it. Now, I want you to name this. Okay, now name the longest chain here, starting from the side closest to the carbon-to-carbon double bond. So we start here, 1, 2, 3. That's our longest chain. So quite simple. This here is just propene. Yeah. We don't call it prop-1ene because it would always be prop-1ene, so we just call it propene instead. Yeah. Next one. That's a wee bit harder, but it's the same principle. Start from the side closest to the carbon-to-carbon double bond. So is it here or is it here? So this one's got 2 carbons, so that would be 1, 2, 3, 4. And then this one would be 1, 2, 3, 4. So it doesn't matter what side we start from. So that would be 1, 2, and then this would be 3, 4, and then that would be 5, 6. Okay, so because it's 6, it's hex. And the carbon-to-carbon double bonds between carbons 3 and 4. So that would be hex 3 ene, because it's an alkene. And the last one is a challenge. Okay, it contains a branch. Now, would you ever get a question like this? Probably not. However, you never know. You never know. So again, start from the side closest to the carbon-to-carbon double bond. In the case of this one, it doesn't really matter. I'll just start here. So that becomes carbon 1, 2, 3, 4. Okay, what carbon have we not included in our longest chain? This one. So this must be a branch, just like so. Okay, now our longest chain's 4, so that is but. In fact, I'm going to write it here. That is but. And the carbon-to-carbon double bond is between 2 and 3, so the smallest number is 2, so that's but 2ene. But we've also got a branch. Okay, where's the branch? It's on carbon 2. And how many carbons does it contain? Only 1. So you should know by now this here is a methyl branch. And it's on carbon 2, so it's 2-methyl but 2ene. It's a tough one. If you've got that, well done. Okay, right, that's us. I'm putting up more past paper questions on Teams, so give them a go. And remember to upload them to the assignments. Thank you.